sign up, right? For people who have not seen the LinkedIn pages and LinkedIn posts around what a round table is, why we are conducting, this is our first time too, and it will be your first time also, right? We'll be talking about high availability and how high availability could be done in various form factors and other various architectures and stuff. Right? First of all, we will take a look at first talk, which is from Lahari Giddi. Right? The talk is about how do we set up multi-master application and what are some of the ways that PgEdge supports in setting up multi-master application, which it itself is a complex topic, I would say. Right? Lahari has been with PgEdge for 1 year and I've let her introduce herself, but she's our second time speaker. She had done a talk at the same place, I believe. So this is her second talk. Good luck and nice
Hi everyone, my name is Lahari. I'm working as SDE in PgEdge. So let me tell you a single line in PgEdge. I don't want to discussion because after that Hari will tell you about PgEdge involved. So PgEdge it's an completely provides a completely open source 100% Postgres. Also it helps us to set up a multi-master replication. So this is and let me get into my presentation. So what I'm trying to say, my title, what it actually says, it is telling about setting up a multi-master replication using 3 ways. So now I clearly give you what are those 3 ways and how can we set up a multi-master replication. So we all know what a multi-master replication is. The name itself suggests that since it has multi-master, which means it has an n number of nodes where each node can act as a master and we can do read and write operations concurrently. And in this multi-master application, we have one major challenge which is known as conflict resolution. And why this conflict resolution occurs? It occurs because when all the nodes try to work on the same piece of data simultaneously, then the conflict resolution occurs. And there are some mechanisms to overcome this conflict resolution, but I am not going to discuss all those mechanisms right now. And one more thing is, one more advantage of this multi-master application is, it provides high scalability and readability. Why? Because since the data can be distributed among all the nodes, so obviously there is a chance of high scalability and availability. And so this is my main topic where we can see the 3 approaches how we can deploy, how we can set up a PgEdge platform, and with this PgEdge platform, how we can set up a multi-master application. And first one is script-based configuration. And what is this script-based configuration? So we write scripts in Perl and as well as in Python language. So it is a user choice. You can choose whatever language you need, and also you can integrate both Perl and Python as well. So when you run the scripts in Perl followed by Python or Python followed by Perl language, there will be no conflict, or you can see you can run the scripts seamlessly. And yeah, and we can see we are using here a tool called runner, where we can keep all the scripts in a schedule. And when we start a runner, it runs all the scripts. And the major advantage here is, since we have a log file here, we can easily find out where the error, if error exists, we can easily find out where we are getting that error. And then it's almost hands-free. And one more thing is, here the values are hard-coded, means we are using a config file where we can easily define the path, port number, or the number of nodes that we want to create, and the extensions that we need to create, versions of it, like you can install PG16, PG70, or whatever the version you like to. And let me give a demo how this is done.
You wanna go through the other two approaches also and then start the demo at the end, if that is easier.
And next one is the Docker-based setup. In this Docker-based setup, you are going to pull the PgEdge specified Docker image, and from there on, we are going to set up a PgEdge platform, and the nodes created, and the extensions created, subscriptions created, and tables are created, and those and also sets created, and then command-driven deployment, which means that we can manually run the commands, and then we can see how this setup is going. You can witness it clearly, what are the commands that we are using and how it is working, and you can get a clear vision of what actually going through while you are running these commands. So this is a Docker-based setup, and you can say it's. Let me go over the demo. So here you can see that what command I am using, /runner.py, and the scripts are in schedule file. Yeah, the scripts are in schedule file, and these are the scripts I am going to run. So I'll show you the log file. So here you can see the first script which installs PgEdge, and the commands here we are using a curl command, and here it is we have two things here. One, here we are representing the upstream and also the download. Now we are using upstream here, so this is a command that we are using, and one more thing, and the next script sets up and load one. Means it actually creates a particular directory where it creates a cluster. Means it is used to set up a 2-node cluster here, and then in the third script you can see the list where we can have all the extensions that we have, and Particularly, we are focusing on Spark 32 and also on Snowflake, and those two are installed. And the same way, the node 2 is created, and in the same way, in node 2 also, we are going to install Spark 32 and Snowflake. And in 8051 script, you can display the node with node ID, and in 8052 with node 2. And here I am going to run the PgBench. PgBench, and this is all with which is used in which we can create 4 tables, and then with the same script I am also using to drop the PgBench, remove PgBench, and also at last we can remove PgEdge. These are the scripts that we are using, and it almost takes less than 5 minutes to run all these scripts, so you can easily have a PgHyd platform and you can use it. And this is about through script based. And next I'll show you with Docker based setup. And this is about the Docker based setup, and the command we are using here is Docker compose. Yeah.
So whenever you say I will go ahead and call. We're talking about this. You want them to force something? Okay.
You see, since it is download, the SQL version is 24.1.3. The API setup is 24.1.9, which is in upstream. If it is in downstream, the SQL version is 1.9.
Which language? All of it, yeah. The entire development is on.
Here, the extension created here is Snowflake PG16. So, what is Snowflake? So Snowflake replaces the Postgres, what you can say that, big serial data type into int8 and sequence-based solution. Means it creates a Snowflake sequences, and the Snowflake sequences is in 64-bit integer, where the bits from 0 to 9 represents an unique node number, and the bits from 10 to 12 represents a counter type, where 12-bit counter, where it increases the value for ID allocation, and from 12 to 62 it's an timestamp, and from bit 63 it's a bit which you can say it as an sign bit, like either it can represent a negative sign or a positive sign. It is a single bit, and that is about Snowflake extension. And next. And next you can see that Spark 32. Now the version we are using is 3.2. So what Spark extension is, it is mainly built under a very strong, basically block called bidirectional replication. And the features of this Spark are, it supports PG14 and it supports PG17 development, and also you can talk about the use cases like it supports an asynchronous multi-master replication, and it is used for selective replication of tables for a particular replication set, and it is used for selective replication of table rows either from publisher side or from the subscriber side. Comparatively, you can see when you set up PgEdge through Docker, it is almost taking a 3 minutes, almost 3 minutes time. But when while you run through the scripts, the time is very less. So this is one of the advantages. So one created in N1 and executed in N1 and nodes executed in N2. Tables created. Yeah, this is through Docker.
PgH offers, right? Deployment models of PgH offers.
That is correct. So, what Lahari is, Lahari started with is the 3 options that PgEdge has in installing your 100% Postgres and an open source multi-master extension, which is POP. One of the options that you saw first is the script-based one. Like all of the scripts are built in either Perl, because we wanted to be community centric. So all the entire testing of Postgres suite is in Perl. It's developed in Perl, so we want to be in line with that. Because the entire NoSQL code is written in Python, we also wanted some of the tests in Python. We wrote a few tests in Python. So when Lahari showed the first setup iteration, it was having both Perl scripts and Python scripts. So it had gone through bring about the repository, right? The repository and bring about what are the targets that needs to be set up for installing PgEdge, Postgres, all the extensions that needs to be part and parcel. The Docker base is like Prashant has made more built-in Perl, and it's a quick setup for developers to just bring up two nodes. It's based on PgEdge's Docker image, and we go ahead and create Spark extension, Postgres 16, PgTune, and we also go ahead and set up two nodes and set up a sample table and the PgBench on top of it. Make sure both node 1 and node 2 are talking to each other. That's the whole setup that Lahari has shown.
Not for the production, right? It's for developers.
Yes, it is more of developer-centric. For production, we have a guide, development guide, and documentation available on PgHyd.com, which will go through setting up not only all the instances, what are some of the prerequisites that you should have before setting up your production system, right? Making sure only 5432 and your connection port is open between the nodes and all of that, right? All of that is part and parcel of the documentation. This is to more of let a developer pick up PgEdge platform and start using it right off the bat.
Any questions?
The next setup is through command driven, where you can manually set up commands. Like you can see here the Perl command that we have used. So, like same in Docker, how you can see the CLI versions and all. The same way with this command, the PgEdge platform is set up. And the next thing is, and the next thing is, you can install PgEdge with giving a password user and the database created, and where you can see the same way the Snowflake extension is created and the Spark extension is created, and then on that you can run the PgBench commands. The commands provided here, like you can see PgBench install with the database created, like it is demo here and use, and the other command is with demo and a replication set, and the other is with running a PgBench command with given a particular time and date, and you are validating it, and then you can remove this. So these are the three ways that you can use PgEdge. Any questions, comments? Any questions or comments?
So the deployment options are on-premise as well as on cloud, or
Deployment options?
are on cloud as well as in cloud-based support? So your multi-master, you are going to set up right the different masters. So what kind of options do you have for those servers to be deployed? Is it going to be on-premise? Is it going to be mixed?
So basically, there are two products of PgEdge. One is the community-oriented one, which is PgEdge platform, and then there is another one called as PgEdge Cloud, which is the SaaS or the DPaaS offering from PgEdge. Just because we do not want to get into the theatrics and the dynamics of a closed source plus a SaaS software in our core, we are restricting and limiting our discussions to PgEdge platform. For your question, PgEdge platform does support multi-cloud. We have set up clusters on AWS plus GCP, AWS plus Azure. So PgEdge platform as a platform, as a product, it could be set up on multi-cloud. When you talk about the PgEdge cloud, I mean again it is multi-cloud again. It is more of a database as a service, right? The entire support, the entire managed services are with the PgEdge support team.
Also writing most of this is in Perl. Are these not available in Python also?
So the test cases are available both in Perl and Python. Some of the modules are written in Perl, some of the modules are written in Python. And it's just the developers' choice, I would say. Right? And all the test cases are available on the GitHub. You can just go jump in and say, hey, no, I don't like the way you guys have written the test case. Probably this is the right way of writing this. Yeah? Thanks so much.